Thank you, Kim, and thank you, Janet, too, for a wonderful introduction. So it's a real honor for me to be here representing the Commission and introducing this symposium celebrating 50 years of the ESA and also the animals that they save. So 50 years ago, both the American public and Congress, as we heard from Janet, really recognized the intrinsic and the aesthetic value of whales, as well as their commercial and recreational importance. And this was a huge shift from the perception from years before, where essentially marine mammals were either seen as vermin, competing for fish, or as a commodity. We were harvesting seals and sea otters for fur. Whales were important for baleen and whalebone to keep us skinny looking, and ambergris from spur whales. So there was this big shift about 50 years ago that really rose out of a number of different issues. There was basically widespread disgust when the scale of commercial whaling was really exposed. And then there was further sort of revolt about killing baby fur seals. And those of you who are millennials or Gen X, this is Brigitte Bardot in her younger days. And she used her star power to really bring attention to what was happening on the ice fields when baby seals were being clubbed. And then thousands of dolphins were being killed in the tuna industry. And for drawing attention to that, we really have to thank NOAA's Bill Perrin, who brought his intellect to the issue and really opened up our eyes to what was happening in order for us to be able to eat tuna. So these sort of issues really began to gain awareness. And then in addition to that, Roger Payne released his best-selling LP, making people aware that whales could sing. So suddenly, 50 years ago, whales were now not a commodity, but they had value, they had social interactions, they could sing. So this really led to a sort of big shift in public thinking. And in 1971, Greenpeace coined the phrase, "save the whales," when they set out to block a Russian whaling vessel in 1971. So imagine this happening now, a large inflatable whale over the mall. And then furthermore, in '72, there was the National Conference for the Human Environment. And that conference was really about preserving and conserving the human environment. But what happened there was a call for a moratorium on commercial whaling. So that was considered part of the human environment, and that was 1972. So there's this huge movement from both the public and politically to protect whales, to stop this massive slaughter and also of seals and dolphins. So this movement led to Congress passing, as we heard from Janet, unanimously in 1972, the Marine Mammal Protection Act, and the following year, the Endangered Species Act in its third version, which is essentially what we have today. And this, we really have to notice that the US was a world leader. By passing these two acts, that essentially stopped not just the taking of marine mammals in US waters, but the import of marine mammal products into the US, which were really coming from commercial whaling around the rest of the world. So it wasn't until 1982 that the IWC recommended a moratorium on commercial whaling, which wasn't to be effective until 1985. So the US here was over a decade ahead of the rest of the world in protecting our whales. So that's something we should be proud of and we should continue to be world leaders in. Another big issue about these laws is that they not just called out for protection of the whales themselves, but also the ecosystems upon which they depend. And this is just vital, I think, as we move forward for the next 50 years, to realize that we have these ecosystems. It's not just the whales that depend upon them, but ourselves as well. So we have these laws, they protect whales, they also protect the ecosystems upon which they depend. So where are we now? Well, a lot has happened in 50 years. First of all, we've managed to double ourselves. There are 8 billion people on the planet today, so that's twice as many as there were when these laws were passed. And if you put this in context, this is a paper looking at biomass of humans versus other animals on the planet. And we have actually 40 times as much biomass as the baleen whales. And if you think about that, I'm a lot smaller than a 300,000-pound blue whale, but still there's a lot more humans than whales. So there are a lot of us, and we share the ecosystem, as I said earlier. we're also losing ice, upon which many marine mammals are dependent. This slide shows loss of the Arctic sea ice in September, and now we're looking at a 12.2% loss of Arctic sea ice at the end of the summer per decade. So things are going downhill as far as ice is concerned. But then we have a little bit of the good news 50 years on from the whales' perspectives. So no marine mammal has gone extinct in the US waters since these laws were passed. And I have a sort of bad joke about it was China, but we won't do that too much today. But if you look at these two graphs at the bottom here, you'll see these represent the northeastern population, the Pacific gray whale on the left, and North Atlantic right whale on the right. And the purple bars are the catches. The red dots are real population estimates based on the animals themselves, and then the lines are the models. And you can see how the Northeast Pacific gray whale population has really rebounded, but yet we are still fighting here to help recover the North Atlantic right whale. And it's not only the North Atlantic right whale. Many of us here have heard the term the urban whale, because North Atlantic right whales share the eastern seaboard of the US with us, that is really heavily urbanized. But today we're also going to talk about and celebrate the eastern population of the North Pacific right whale, and of course our Rice's whale that is new to us, but also vitally important. And so although we talk about the North Atlantic right whale as the urban whale, I want you to think about the fact that the North Pacific right whale is currently inhabiting waters that for many years did not have much human activity. It's not an urban area up in the North Pacific. But as we lose ice and these waters become accessible to industry, naval activities, shipping traffic, they too are beginning to be facing a more urban environment and be facing some of the threats that the North Atlantic whale faces. So let's think about its future as well as we move forward today. So we've managed to stop the direct killing of whales by humans, but we now still harm whales. But these threats are now indirectly due to our activities. And here on this slide, we list them. I think we're all very aware of ship strikes. This is a gray whale in San Francisco Bay with a vessel possibly involved in its demise behind it. So ship strikes are a common cause of death of our large whales. We can see them, we can diagnose it because they have big wounds on them. Entanglement in fisheries is a well-documented tangling, a thorny problem for us. And today, you can see the example of a whale that was killed by plastic ingestion when you go back and look at the Rice's whale. And then there are toxins that we produce that accumulate in the environment, harmful algal blooms that are increasing because of our increased use of nitrogen, increased runoff into coastal waters. And also, as we move ballast waters around, we're also moving around harmful algal blooms and toxins that are in places they didn't used to be. Infectious diseases are emerging and are spreading. I think many of you are familiar with the fact now that avian influenza is killing thousands of marine mammals in Argentina and Chile in the south, and it may be a matter of time before we see cases here. And then finally, climate change, of course, is exacerbating all of these indirect impacts of humans on marine mammals. So for those of you who were with us the last 2 days, the Marine Mammal Commission spent the last 2 days listening to experts on the cascading effects of climate change on marine mammals. And for those of you who thought it was great, you can listen to it all over again. And for those of you who missed it, these talks are available on our website. But essentially, we reviewed what we know about the impacts of climate change on marine mammals and what we should be worrying about as these cascading effects that initially affect the physical properties of the ocean, which in turn affect the biological properties, which in turn affect food at the bottom of the food chain, but can finally result in impacts on whales, on their health, on their reproduction, and on their survival. So climate change is really driving a lot of what we see today. Even if there are indirect effects, they finally can result in death of animals and declines in populations. So given all this, how do we move forward? How do we continue to save whales in the future? We had this energy 50 years ago, and now we realize that many of these impacts are not direct killing. It's not as easy to go out and just say, stop doing these horrible, bloody things that we were essentially disgusted by. Instead, what we're trying to do now is to curtail human activities, we're trying to stop some of the things that these 8 billion people do on the planet that indirectly affect marine mammals. So it's much more of a challenge to tell someone not to do something that they don't really know affects a whale. If they did, they might not do it. So our challenge here, as people who are, I think everyone in the room is a whale enthusiast, we have to learn how to talk about how to value these animals. Why should we value whales? Why should everybody else? And why should perhaps they make compromises? So the first is obviously linked to the ecosystem. We know that whales are an integral part of the marine ecosystem. They are part of, they contribute to nutrient cycling in the ocean. Whales may feed lower or at the bottom of the seabed, and as they come to the surface, they release products, feces, urine, placenta, skin, and thus stimulate phytoplankton production and contribute to developing the lower parts of the food chain, and are thus very much part of the cycle of nutrients in ocean waters. And this has been referred to some as the whale pump, and essentially this is the whale pump in action. So material from the bottom comes to the top. Whales not only are part of the nutrient cycle, but we can also think of them as part of the carbon cycle, and that they all can be part of carbon sequestration. So when a whale carcass is a whale is alive and at the top, it's big, it eats, it puts carbon into its body. And then when they die, they can sink to the seabed, and at the seabed bottom, they will retain that carbon and prevent it from being exposed to the atmosphere. So they're essentially carbon sinks, literally, and can be part of our solutions to climate change. And then I think there have been a number of studies that make it very clear that whales can contribute to coastal economies and to ecotourism through their value as animals for people to actually see. Like we heard from Janet, how she was inspired by seeing a whale. And many people are, and there's nothing more amazing than to go out on a water and see a whale breaching in front of you. And there are a number of studies that show the actual numerical value of whales to coastal economies. And then the final reason that I value most is that whales are really sentinels of ocean health. We consider them sort of canaries in the coal mine. They give warning of what's happening in that coal mine, what can be happening to them that might impact us and might damage our health. And this is because they're long-lived, they're at the top of the food chain, they're at a high trophic level, so toxins that come into the food chain will accumulate in their bodies, and because they'll be at higher levels, longer, because they're longer-lived. And as their mammalian physiology is similar to our physiology, if we see impacts of toxins on them, they're likely to also be impacting us if we ate similar doses. So they're essentially early warnings, for example, that DDTs can cause reproductive failure, but harmful algal bloom exposure can cause not just death, but also reproductive failure and cancer. So I think the death of large number of whales in harmful algal blooms has recently really brought attention to the fact that these algal blooms are increasing worldwide. There have been a number of papers that show how coastal algal blooms are increasing. The top is a map of coastal algal blooms. Red are the areas where they're increasing, blue decreasing, and you'll see a lot of red around the world. And at the bottom, we have two lines, one that shows the frequency of coastal blooms in blue, and then the affected areas in red, both of which are increasing. So these graphs aren't really inspiring. It takes a while to look at them. It takes me a few words to explain the red and the blue. But when you have dead whales, they're really obvious. It doesn't take much explaining. And in fact, it was in 1987 that humpback whales died in Cape Cod Bay after eating food containing saxitoxin produced by a harmful algal bloom. So Joe Girassi was the first to recognize this impact of harmful algal blooms on humpback whales. And that was back almost 50 years ago. And then since then, we've seen more deaths of whales because of harmful algal blooms. In 2008, there was a mass mortality of not just whales, but also seabirds in the Gulf of St. Lawrence. And then in 2015, there was the largest reported die-off of whales ever, of over 300 sei whales being observed around southern Chile that had died because of eating saxitoxin. We don't know, but we think some of that increase in saxitoxin around southern Chile is associated with the increasing numbers of fish farms increasing nutrients in those coastal waters. And then just last year, adult female southern right whales were observed dead off Peninsula Valdez, and these animals just died suddenly, dramatically, after eating blooms with saxitoxin inside them. So these whales really draw our attention to these increasing harmful algal blooms worldwide. Not only did they bring attention to harmful algal blooms, but in 1987, there was also a viral epidemic that killed bottlenose dolphins along the east coast of the United States. So the combination of dead whales and dead dolphins, again, led to change in Congress. And what happened then was that the Marine Mammal Protection Act was amended and the stranding network was created. The Marine Mammal Health and Stranding Program was part of Title IV, part of the amendments to the Marine Mammal Protection Act to make us also think about health of marine mammals beyond mortality in fisheries. So the stranding program, and we'll hear more about it today, but it's a phenomenal network of people around the country who have dedicated to responding to marine mammals when they wash up on our beaches, dead or alive. Some people are driven by welfare concerns for live animals. Others are driven by science from the dead animals. But all these people work together to generate information that we can feed into NOAA fisheries management needs and provide information that is vital to thinking about how we can protect these marine mammals. And I wanted to give a little totally low-tech example, because today we're going to hear about some really high-tech examples. But this picture on the bottom is the first photo of a beaked whale, Mesoplodon hotuala, that had been only known from dead specimens. And the stranding network, way out in the Pacific Islands, saw this whale, observed it, reported it in to Christy West, who coordinates responses to cetacean strandings on the Hawaiian Islands. And she thought, this is fascinating. They had nothing with them, so they used a high-tech kitchen sponge, managed to stroke the surface of the whale, collected a skin sample, and then that was used to genetically identify the whale and confirm that this was the first sighting of this rare whale in the Pacific. So the stranding network has amazing resources, kitchen sponges, you name it. But today we're going to hear about another whale that was also identified through the stranding network. And I'm not going to jump and steal anyone's thunder, but I think we'll see that we have gone a long way beyond kitchen sponges. And so speaking of scientific advances, it's not only 50 years since the Endangered Species Act was passed, but it's 60 years since the first international symposium on cetacean research that was actually held here in the DC area. And so we've gone a long way in those 60 years. And I wanted to show this slide because we have the eponymous Dale Rice, second from the left. So for those of you who think about Rice as a whale, he's a person. And actually, we also have Amura on the right, also eponymous scientist. And I think you may recognize many other faces. And there's one in the middle of the back who hasn't changed much in 60 years. So over 60 years, what have we learned? Science has really advanced. We're going to hear today about a whole suite of information on whale biology, ecology, health and disease that has come through our science. So our science has really advanced. There are big changes. So really think about that. If we look back to 50 years, we look back to 60 years ago, when this first research symposium was held, we have come a long way. So for example, 50 years ago, we were excited to hear that whales could sing. Now we have scientists that want to know what language sperm whales are speaking by using machine learning. So there are phenomenal advances in technology. We have come a long way with our science. And so what we need to do now is think about how do we use that? How do we go forth? What is the future for our whales now that we're 50 years since the passing of these laws? So my thoughts are that the ESA and the MMPA have really been vital to whale conservation. We still have them all in US waters, and we want to keep it that way. But these laws have also been vital to protecting their ecosystems. And the harsh reality today is that those ecosystems are also important to 8 billion people. So we have to figure out how are we going to protect those ecosystems, but also protect the livelihoods of people who are dependent upon oceans for fisheries, but also for recreation, for shipping. So we have to figure out how we can together move forward in these ecosystems. But we do have new technology, and I think at this point we should really think about how do we use these technologies to inform adaptive management so that we can truly continue to protect both whales and their ecosystems. We have information, we have tools, we have ways to find ships, we have ways to find whales, we have ways to fish without entangling whales. So we really need to use them. So I guess I'd just like to finish to say, I think we can all, as scientists, as policymakers, really let's rise to this occasion as we look to the next 50 years. And as we combat climate change, we should continue to save the whales because we can do both. So with that, I thank you, and I'd just like to welcome you all to the real science that will be coming up later. Thanks.